Hello, everyone, and welcome to another session of our Day One and Beyond Security Series, where we take you through different topics and activities related to building out on Oracle Cloud. Today's session, we will cover OCI Identity and Access Management, what's available today, the advantages for customers, and how easy it is to get started. I'd like to introduce Kieran and Mohammed as our main presenters today. And now I'll hand it over to Kieran to begin today's session. Thank you.
Thank you, Brendan. As Brendan mentioned, my name is Kiran Thakkar. With me today, Mohammed Halim. We both are Master Principal Cloud Architects as part of customer engineering team. And we work with customers and help them with security services on OCI. And identity is one of the security services we work with. Thank you for joining us today. Let's begin. Oracle has been a leader in identity and access management space for many years, starting with enterprise SSO product that Oracle built for Oracle Enterprise applications. Then Oracle acquired Oblix and Accelerate that established Oracle as a leader in identity and access management space. We later on renamed those products as Oracle Access Manager and Oracle Identity Manager. You must be familiar with those names if you are in identity and access management space. We later on also added Oracle Entitlement Server. Since then, we have had hundreds of customers using Oracle IAM products. We have also built cloud native, cloud first identity service, not only for access management use cases, but also for identity governance use cases. All of the Oracle Cloud, that's IaaS, PaaS, and SaaS services that are running on our cloud, use these products natively to enforce authentication and secure access to OCI and services that are running on OCI. Let's take a look at our IAM product portfolio. As you can see in this slide, we have full-fledged IAM products both on-premise and on the cloud. OCI IAM is access management product on OCI and built for OCI. The reason I say built for OCI is because it is used as identity fabric for everything that you see on OCI that includes IaaS, PaaS, and SaaS services. And we have also built identity governance product in OCI known as OCI Access Governance. That is also built from scratch for the cloud in the cloud. For on-premise, we have a full-fledged identity and access management suite of products that includes directory services products like Oracle Unified Directory, an access management product, Oracle Access Manager, along with identity governance product that is Oracle Identity Governance. Along with that, we have also built Oracle Identity Role Intelligence product. In that product, we use a lot of AI to help you sort of run your intelligence around roles and groups in the in your identity governance product, and use the AI use the AI for user entitlements across all of the targets that are integrated with identity governance platform. Access management products, both on cloud and on-premise, are used to implement authentication, single sign-on, MFA, adaptive authentication, and OAuth use cases, while identity governance products are used to implement full-fledged identity lifecycle management, also known as joiner, mover, and leaver use cases. It can integrate with HR system to sync users as they are born and manage their lifecycle until they leave the organization. It also supports running the certification cycles across all the targets that are integrated with identity governance product. Now let's first understand why is identity important. I would like to use weather analogy. There is high pressure system developing, and as we know, high pressure system is not good for clouds. Let me explain what I'm talking about. We are living in a time where every enterprise company has distributed IT environment. What I mean by distributed IT environment is they're running some sensitive and legacy applications on-prem. Some applications are built and are running in cloud. They are also using a number of SaaS applications to manage their business, like Fusion ERP or NetSuite, for example. Each of these different applications are built and managed and operated by various business stakeholders. Oftentimes, those business stakeholders buy and use products and services that IT or security team may not be aware of. If security team is not even aware of those products being used in the enterprise, there is no way they have visibility into those platforms and products. Even if in some cases they are aware of these systems and applications, they don't really have time to learn every possible platform or application that IT is using, and that increases lack of visibility across apps and also adds shadow IT. All the SaaS and cloud platforms that the IT are using brings its own identity silo. So now IT or your security team has to manage user accounts and their permissions across these different heterogeneous platforms. That is exactly where user credentials become the top targets for hackers. If you refer to OWASP top 10 threats, stolen credentials is one of the most sort of exploited vector to hack into enterprise environments. How do we fix this? We follow some basic principles on OCI to fix this. The first one is zero trust and least privilege. What I mean by that is on OCI, we have implemented zero trust. That means we don't trust anything, including network or device, and enforce authentication on every operation or every API call. Provide and second principle is least privilege, which means avoid authorization only for the resources that are absolutely necessary. Do not write over permissive policies. And policy syntax and structure that we have built that we'll take a look at later in the slides basically will allow you to write absolutely necessary policies, and you don't have to write any over permissive policies. The second principle that we follow is assume breach. Just because you have used preventative controls, don't assume that the environment is safe. Implement necessary monitoring and detective controls. Assume that breach will occur and create processes to detect breach and address them. In both these approaches that I talked about, they are basically about identity. It is the only common factor across these heterogeneous apps that IT and product teams are using in the enterprise network, and that is precisely why you all may have heard the term IAM is the new perimeter. In today's session, we will focus on OCI IAM, which is the access management product on OCI and used for all access management use cases. There is authentication, single sign-on across products and services. There is IaaS, PaaS, and SaaS running on OCI. And once I'm done with functional overview, my colleague Mohammed will talk about some of the new features that we have released in OCI IAM in last 1 year. OCI IAM provides three core functionalities. These are essentially the three problem areas that we try and address. First one is it stands on its own as a holistic enterprise IAM platform, providing everything an organization needs to manage user identities and access entitlements across Oracle and third-party platforms and services. While it's a native OCI service, it reaches across other clouds and SaaS services that you could be using in your environment, and also extends to on-prem environments to manage access and entitlement and enable single sign-on across all of the enterprise applications. This obviously enables quick productivity and reduces the effort to meet security and compliance objectives related to identity and access. It also serves as the gatekeeper for control plane on OCI. All of the platform and SaaS applications that we have deployed on OCI that you run and use on OCI use OCI IAM as the login service that provides an integrated and seamless experience for both IAM administrators and for end users. It provides a developer-friendly IAM engine, making it easy to add identity and access functionality to custom and consumer-facing applications. This includes features like social login, user self-service registration, consent management, and a fully customizable user login and profile management experience. The service was designed with an API-first approach, meaning every bit of functionality that's available in OCI IAM is also available through APIs, and you can programmatically invoke those APIs as and when you need them. OCI IAM delivers a significant functionality across all of these three pillars that I talked about. Now let's dig deep and look at OCI IAM product. Being an identity service, it of course provides identity store and identity lifecycle management use cases. And as I mentioned, it is the gatekeeper for all of the PaaS and SaaS services on OCI. So when you try to log into those PaaS and SaaS services, you will see the login screen like this, as you see in this slide. It can also be used to implement outbound authentication and single sign-on to the third-party applications and cloud services that you use in your enterprise, which also includes Oracle Enterprise applications that you could be running on-prem or on OCI or on any other cloud provider. That includes, single sign-on with EBS, single sign-on with PeopleSoft, and any other enterprise Oracle app that you could be using. And since it is the identity fabric for IaaS and PaaS on OCI, it gives you an ability to write IAM policies to enforce who has access to what on OCI, IaaS, and PaaS services. Since it's IAM service, of course, it supports an inbound authentication, and the options that are available are you can implement social login for consumer IAM use cases and applications. It supports federated login using SAML and OpenID Connect, which you can leverage to integrate with your enterprise identity provider, which could be Okta or Entra or any other IDP that you could be using. It supports MFA and adaptive security. I have a slide where we will talk about adaptive security in detail. If your users are stored in Active Directory, which is the case for a lot of enterprise customers, over so many years they've been using Active Directory to store and manage users. We do support synchronizing those users and groups to OCI IAM using what is called as Active Directory Bridge. And Active Directory Bridge can also be used to implement delegated authentication against Active Directory for authentication or login requests on OCI IAM. We also have provisioning bridges that you can use to integrate with your HR systems and bring those users over to OCI. For most of those use cases, we now recommend customers to use our access governance product, which gives you, many more options when it comes to governance and identity lifecycle management. We also support app catalog in OCI IAM, which allows you or which offers you single-click options to integrate with third-party cloud services for single sign-on and user management use cases. It also supports Radius Proxy if you want to implement OCI IAM authentication for Oracle databases. Now, Oracle databases natively support OCI IAM integration, so you don't have to use Radius Proxy. But if you have been using that and you would like to leverage with OCI IAM as well, then it's available. We do have a PAM module as well that you can leverage to implement Linux authentication using OCI IAM credentials. Of course, it supports federated SSO, so you can use SAML and OpenID Connect to integrate with third-party SaaS applications. And we have an app gateway as well, which you can leverage to integrate with homegrown applications or enterprise applications that support header-based authentication for single sign-on. So you can deploy app gateway, which acts as a proxy to those enterprise applications and enforce single sign-on. OCI IAM was designed 100% API first. Every feature or function that's available from the console is first available programmatically via APIs. That's a principle we follow. This makes admin console and user logon screens fully customizable, and you can build sort of your own login experiences as well. We have also built and provide sample code and SDKs to to developers to build sort of developer-friendly environment and adding identity and access management features into custom and consumer-facing applications. And of course, we support social logon for various SIAM use cases. Now let's talk about those features, like double click one more time and sort of talk about those inbound authentication and outbound authentication features. Being an IAM service, it supports various different types of authentication methods, starting with basic authentication. Although we don't recommend customers to use basic authentication, most customers are moving away from basic authentications. However, if you have legacy applications that rely on basic authentication and you don't have time to rebuild those applications or support modern authentication for those applications, we do support basic authentication for those use cases. For integration with your enterprise IDP, we support SAML, OpenID Connect, and we also support OAuth for API authentication and authorization. We support numerous options for MFA. That also includes support for passwordless authentication. Adaptive security gives you an option to evaluate risk of any authentication operation real time based on some context variables, and we'll talk about what those context variables are in the next slide. And we also support delegated authentication to Active Directory, as I mentioned in one of the previous slides. As you can see in this slide, we do support adaptive authentication, where we evaluate risk of any authentication request based on which device that you're using. If you're using this device for the first time, then we can increase risk score of that authentication operation and ask you to go through MFA. If you are logging in from, let's say, Starbucks outside of your enterprise network, then we can detect that and challenge you for MFA, or at times deny authentication. Based on which group you're part of, you can implement different sign-on policies for internal versus external users, for administrators versus non-administrator users. And we have also built risk engine, which basically enforces or calculates risk score associated with any authentication operation based on user behavior. And these are the factors that you can use to configure risk score, and you decide what is the risk of any particular event, and based on that, risk score is calculated for that user for that authentication operation. And then you can write policies that says if the risk score is more than, let's say, 80%, then do MFA. Or if the risk score is more than 90%, I want to deny access. If the application is sensitive enough and you don't want to take chances, you can really deny access if the risk score of authentication operation is more than 90%. And for MFA, the factors that we support are mobile push notification, mobile TORP, SMS, knowledge base, bypass code, DO security, FIDO, and an extension of FIDO is basically we do support passkey authentication as well. This is a list of all those MFA authentication factors that we support on OCI. And as I was saying, we do support passwordless authentication as well. So when user is created, user will get an email to activate the account. And as part of profile activation, we will ask user to enroll to an MFA, and that could very well be a passkey, which is then stored in your iCloud or stored on your device, and then you configure passwordless authentication, so users will use just that one factor to log into OCI. And this extends to Windows Hello authentication as well, so you can use this passkey option to use Windows Hello for authentication operations. For outbound authentication and single sign-on, we support SAML, OpenID Connect, and OAuth. And we have an app catalog of more than 1,000 applications, which allows you to do like single-click SSO and user lifecycle management integrations with a bunch of third-party SaaS applications. We do support just-in-time provisioning as well, both for incoming, and then you can add custom attributes in the SAML assertion to implement just-in-time provisioning in the target. And we have app gateway as well if you want to integrate header-based or proxy-based SSO applications. And that also includes EBS asserter, which you can leverage to implement SSO for EBS authentication. For identity and user lifecycle management, of course, you can create and manage users through OCI console, but that's not very sort of developer friendly or automated way of managing users. So we have full-fledged SCIM support that you can leverage to create and manage users in OCI IAM. We do support just-in-time provisioning as well if you don't want to use SCIM and create users on the fly, which is what a lot of customers use for SIAM use cases along with social login. There are a lot of different types of authentication factors that you can manage for users, starting from database credentials, auth tokens that you use for container registry on OCI. All of those can be managed through both APIs, SDKs, Terraform, and again through console as well. Now, before I talk about IAM policies, I want to spend some time talking about compartments, because only then IAM policies would make sense. Compartments are fundamental organizational construct in OCI. You use compartments to create a collection of related resources in OCI. And compartments give you a logical isolation between resources and service instances that you're running on OCI. And what I mean by logical isolation is, for example, if you have two resources in the same compartment, but if they are in the different network or different subnet, they won't be able to talk to each other. Even though they are in the same compartment, they cannot talk to each other. So the communication channel between two resources is enabled through networking configuration, but you can group them together in one single compartment to do access management, cost management, and security policy management, which is enabling CloudGuard for these resources in your OCI tenancy. The compartment hierarchy is a tree-like structure, as you can see in this slide. And this hierarchy can be as deep as 6 level. The compartment structure and hierarchy is not set in stone. What I mean by that is, once you create compartment structure and then later on you realize that, this app now belongs to business unit 2, you can really move this application from this app dev business unit 1 compartment to app dev business unit 2 compartment. Of course, the policies that you have written will have to be addressed and make sure the policies are addressed appropriately as well. But the structure itself is not set in stone, and you can change the structure as you onboard more workload on OCI. This is a diagram showing what is compartment hierarchy. And the reason I include this diagram is we have recently changed limit on number of policy statements that you can create in the tenancy. We used to enforce number of policy statement limits at the tenancy level, and we have changed that now, and we enforce that limit at the compartment hierarchy level. So for this compartment structure that I've shown here, these are all different compartment hierarchies in your tenancy, which is, from root compartment to business unit one, app dev one, app one, production. This is one compartment hierarchy. Second compartment hierarchy would be root, business unit one, app dev, app two. That's the second compartment hierarchy, as you can see in this diagram. And number of policy statements that you can write in your tenancy are enforced at the compartment hierarchy level. The default limit is 500. You can create 500 policy statements for every compartment hierarchy that you can see in this diagram. You have to be diligent, however, to figure out where do you write any policy. As you can see here, if you write any policy in root compartment, that policy will count towards every compartment hierarchy policy statement limit. That is why, as long as possible, you should write policies in the leaf compartment, but you can, in theory, write policy at any level in this compartment hierarchy. And any policy that you write for, let's say, business unit one compartment will be enforced on all of the children compartment as well. That includes this app dev, app one, app two, production, non-production, all of those compartments. So that's how policies are inherited. You can create resource at any level in this compartment hierarchy, even though business unit one compartment, for example, has children compartments, you can create resource and IAM policy at that level. These are a couple of compartment structures that I've shown here for your reference. This is one compartment structure that you can implement where you implement department level isolation using compartments, and under every department compartment you create compartments for every project that the department owns and manage. Under every project compartment, you create compartments for lifecycle management, that is dev, test, prod. And then inside lifecycle compartment, you can create compartments for different tiers of the application, that is front end, middle tier, and database tier. That's just one compartment structure. We, however, recommend customers to follow landing zone compartment structure, which is shown right here, which implements functional isolation between compartments, meaning for security function, you have a compartment and you create all the resources related to security services in that compartment. You have a database compartment for all the database function related resources. You have app dev compartment, which is where you deploy all of your application resources. And you have network compartment, which is where you deploy networking for all of the applications that you deploy on OCI. Compartments are used in OCI for costing and security policy enforcement as well, which is the CloudGuard policies and security zone policies. So you got to be diligent enough in designing your compartment structure and make sure you get it right. My sort of single line recommendation for compartments is try to align your compartment structure with how you manage your business. If you have different functional teams, which is the case for most of the enterprises, we recommend that you implement landing zone compartment structure, which is here. But if you do not have like functional teams, and instead every product team or every application team has its own database team, has its own networking team, has its own app dev team, then the compartment structure that is shown on the left-hand side makes more sense. So there is no sort of one compartment structure that works best for all customers. It really depends on how you manage your business and how you manage your OCI tenancies and workload that is deployed on OCI tenancy. Now that we have understood compartments, let's talk about IAM policies in OCI. IAM policies is what you use to enforce authorization for IaaS and PaaS services on OCI for control plane operations, meaning who can manage network resources, who can manage compute resources, who can create additional compute resources, who can create, let's say, Exadata cluster in your OCI tenancy. All of that is managed by IAM policies. IAM policies follow English language like construct, as you can see in this diagram here. So you say allow group, the name of the group for which you want to allow access to manage is the verb for which you want to grant access. All resources, that is where you define what is the target resource, and then the scope of the policy, which is in tenancy or in compartment XYZ. And that is why I covered compartments first, so that you understand what compartments are when you look at this IAM policies. You cannot really write policy for users and say allow user Kiran Thakur to manage whatever in your compartment. You have to create group of users, and for those groups of users, you write IAM policies. Compartments, as I mentioned, provide security boundaries inside OCI tenancies. We also support time and location-based restrictions, so you can add where clause and say allow that access if time is Pacific working day time. We also support location-based restrictions, meaning you can write policy and say, allow access only if you are accessing from your enterprise network, and if you're connecting from Starbucks, then we will deny access to those resources. And these policies are enforced for all of the interfaces that we support for OCI control plane, which includes console access, which includes SDK, which includes CLI. All of them will enforce these set of policies uniformly. All the IAM policies and compartments that you have in your tenancy are auto-replicated to all the subscribed regions, and Mohammed has slides where he digs deep into that replication and how does that help implement HA and DR. And you can tag your resources as well and use those tags in IAM policy in where clause, where you say, allow some group to, let's say, manage virtual network family resources in compartment network, where target.resource.tag namespace dot, let's say, lifecycle environment for those networking resources is production, or deny access if that is, or allow access only if it is non-production environment. That's the other option. And we have recently added some more features here for IAM policies that Mohammed will cover as we go forward. So that's all I had to cover. And as I was saying, Mohammed will now cover some of the new features that we have released in OCI IAM service in last 1 year. Mohammed, over to you.
Thank you very much, Karen. That was a great overview. So, in this section of the presentation, we'll be focusing on these new features that were released in the last year, and some of them are really interesting features and very popular with customers. So let's start and let's sort of dig in. Let's see what the first feature is. The first feature is the identity access management deny policies, and like Karen was mentioning, we introduced some sort of more new features with regards to sort of policy and policy management. And we all understand that by default, everything is implicitly, cannot be accessed. So implicit non-access to all resources in your tenancy. That's by default, and it's implicit. So customers were asking for an explicit mechanism where I can actually introduce an explicit restriction mechanism, rather than just relying purely on the default restriction mechanisms. So if you look here at this diagram on the right, by default, everything is like deny all. So a user or user group is not going to have access or permissions that entitle them to access any resources in the all resources in the tenancy. That's by default. And then usually what happened is that the customers here, using that sort of green box, they would overlay their policies on top of that, whereby they can actually, where they explicitly grant access to resources. So here I'm explicitly granting manage access to resources A, B, and C, right? Now, on top of that, now with the deny policy mechanism, we're actually now allowing tenancy admins to be able to say, okay, for a specific group, deny, for example, this delete access on resource B, or in fact even deny access to resource B, and that deny statement overrides all permissions that are granted through the policy layer here in this green box. So it is, the deny policy is effectively an override mechanism. It's an explicit resource access restriction mechanism. And the key features here is that the deny policies will override allow policies. So as you can see here, this box here overrides, your green policy box. And we have now, with this deny mechanism, we have like a deny action now. So our policies, the green policies, were basically all starting with the action verb allow. So now we've introduced a new action verb, which is deny, and the same kind of rubric here now. Deny subject to verb on resource type. So deny group, and our subjects are always groups, right? To delete, for example, that's the verb or the meta verb, and then you specify the type of resource, right? So delete, for example, compute family or compute instances in, and then you specify the scope. The scope could be a compartment, could be tenancy level, and then you can also kind of restrict that and basically, add a work clause predicate here. So exactly like we do in policies, but, using that deny action verb. And this also lends, besides making that restriction explicit, it also gives us, a lot more flexibility, in when configuring or when building or implementing our policy layer, right? It can be, it's very easy to say to give permissive permissions to a group, and then one by one we pick out certain granular permissions that we want to remove, rather than having to basically list those granular permissions explicitly. I give you full access management on a resource, and then slightly nitpick and remove certain granular permissions. That lends to a more efficient way of actually, organizing and managing policies, and a less verbose mechanism, right? So you're kind of reducing that number of policy statements, because, we have to be mindful of these permissions, the service limits rather, that Kiran was talking about. At compartment hierarchy level, we have a limit of 1,000 policy statements per compartment hierarchy. Seamless integration. Obviously, the way you edit policies right now, we're using the OCI IAM policy editor. You can use exactly the same policy editor to edit your deny statements. And deny policies also work cross-tenancy, just like policy statements or allow statements work cross-tenancy as well. With the allow and endorse statements, you can use the same kind of mechanism, so we can deny, cross-tenancy, endorsements, in this case. Policy limits, we're sharing the same policy limits, so be mindful of this fact that, a deny policy counts like a normal policy, right? So it does count towards that 1,000 limit per compartment hierarchy. Now, let's have a look at some use cases to sort of kind of capture a little bit more sort of the the flavor of how the deny policy works and how useful it can be. In this case, we have like a multinational sort of retail scenario. The retailer here is managing global operations, and they need to basically block streaming services for compliance, right? So this is an example now of, you start with a permission, you start with a policy that's already entitling that compute team to manage your instance families in a compartment. And then, because of a compliance requirement, the tenancy admin comes in post fact and then says, okay, I want to overlay a deny policy on top of that. And it says deny any user to manage streaming family in tenancy, right? And that's a tenancy level deny policy that applies and percolates across the whole tenancy, percolates through all the compartments. And even if one of these compartments, belonging to an organizational department, for example, has an explicit policy that says, hey, allow this compute team to manage the streaming family, by dint of the fact that you have that deny any user policy at tenancy level, it will effectively nullify the impact and the effect of that allow policy. Another use case is a public sector scenario use case. Now, an organization requires, you need to secure network configurations. So you have to basically, that zero trust approach that we talked about, but then you want to basically permit some other services, to basically manage network resources, right? So let's have a look at the allow statement. It says allow project admins to manage all resources, right? That's a blanket, that's an example of this blanket. It's a blanket statement that says, hey, I'm going to give you everything, and then I'm going to take away some granular permissions for you, right? And that's the takeaway here. In that deny statement, I'm taking away the managed network family in compartment gov project. Now, in the olden days, before the deny policy statement was available, you had to basically, in the allow statement, you had to explicitly list all the allowed permissions, and that could cut and go into several pages of granular permissions. So that's a much more economical way of actually managing this particular scenario. Another scenario is like we have this concept of a private service access gateway. Think of it as like a service gateway or a NAT gateway for our Oracle Service Network services. So you can spin up an object service bucket, for example, or an instance, and then you can basically attach a PSA gateway to it. So effectively you're saying, okay, if you want to access this object storage, please use the PSA. But there are also other modalities, and there are other ingress pathways into object storage other than PSA. For example, you can use a NAT gateway, you can use a service gateway. So if you want to basically restrict the ingress pathway to the PSA pathway, you can also do that via policies. So we're going to say here, or allow this group to manage object family. So the same kind of pattern again, give them all the permissions. That statement, that allow statement covers all modalities, all ingress paths, and then granularly take away the non-PSA ingress paths. And that's what's happening here. Deny any user to access this object family in tenancy. That's a tenancy level policy where the location gateway, where the gateway type is not PSA, right? And finally, another use case is like deny any user to inspect all resources in tenancy where the request network is not enterprise network. So you're effectively saying that, nobody can expect any resource within that tenancy unless they're actually, inside the enterprise network. So I think we can see how useful and powerful the deny policy capabilities is. Let's have a look at the next feature now here is workload identification. Now this one is definitely by popular demand. A lot of our customers, obviously, we're in a multi-cloud sort of world these days. So, you'll have a workload, for example, running in OCI, and you have resources that you want to deploy and provision OCI, and you have somebody, for example, running their CI/CD pipeline in GitHub, and they have a GitHub action, and the GitHub action is authenticating using GitHub, so it has an external token, and it wants to use that token to be able to basically manage the provisioning of resources in OCI. So how can you do that without some form of workload identity federation, a token exchange mechanism? And that's what we're introducing here in this new feature. So it's a very popular feature, and obviously for it to work, you have to basically do some kind of prep work. And this one-time trust configuration is essential. So establish that trust, between the external IDP and OCI, and OCI in that case is your relying party, right? So, and then once that one-time trust configuration has been established and configured, we then basically proceed with exchanging the cloud token for an OCI token. We get back the token. And then from that point onwards, your GitHub action script is going to basically be using that OCI token, right, to basically connect into the OCI control plane API endpoints and start provisioning and managing all these resources in OCI. So that's a very popular feature. Let's double click a little bit into it. Now, the token exchange mechanism itself obviously is a multi-step process, but obviously, like I mentioned, before we can actually even start the token exchange, we have to embark on the trust configuration setup. And with trust configuration, it's basically a twofold process. The first process is you have to make sure that, what type of modality do we want to basically, implement here? Are we going to basically be focusing on identity propagation? So your external identity is going to propagate into OCI IAM, in which case you have to make sure that your external identity is also provisioned and configured as a user resource in OCI IAM. But most customers, what they do is effectively they want to exchange or map their external credentials or their external identity with some kind of service user inside OCI that belongs to a group that has permissions. So that service user in OCI then assumes these permissions, and using those permissions, you'll be able to then provision these resources in OCI. So in that case, we need to basically create that service user inside OCI. And you can't do that via the console, so you have to have a client. That client has to have admin privileges. It connects to the OCI IAM service, and via APIs, it creates that service user. And also in that same process, it configures the federation trust configuration. So it uploads the certificates of your external IDP so that effectively OCI can trust that external access token. Now let's go and focus on this green box here. These are the steps. This now on the left here is your workload with non-admin auth client. That's effectively a script. It's a GitHub action script, and it's authenticating with the GitHub action IDP, effectively gets back a token, validates that token. So now we have that external token. Now, as part of this process, and this is an extra step here that you'll only see and only find with OCI, because with OCI, our endpoints or control plane endpoints do not kind of, accept auth. It's not just only an access token, it has to be access token plus signature authentication. So for signature authentication, you need PKI material. You need a private key to sign that request, and you need that public key as well. So what happens is that we generate that PKI, public and private key pair, and then we send a request. We send the external token plus the public key. We send that across to OCI IAM and say, hey, can you give us back a token? Now, this token, we call it a user principal session token. Okay, it's a JWT token at the end of the day, but a JWT token that references and points at your public key, and you get back that token. It's obviously valid, and that UPST token then has to be used along with the PKI. So with the private key, you sign your request and present that request along with the UPST token to your control plane API endpoints. And from that point onwards, you're able to now provision and manage resources in OCI. So that's how we do this workload identity federation and token exchange. And during that discussion, I did mention, in passing the fact that, we need to, the trust configuration requires validation. This validation is at 4 levels. So I think I did allude to this in the previous slide, is that you're validating the token signature. That's important using the JWK URI. You're also doing client claim validation. When we're setting up that OAuth, WIF trust, you're saying, okay, I'm now that's an external token. I'm expecting that external token to contain a certain number of claims, right? There could be custom claims, subject claims, issuer claims, etc. You have to specify which claims you insist on, right? So this is the client claim validation piece. And now the principal validation, like I mentioned, without impersonation, we're talking about identity propagation, full-on identity propagation from external into OCI. Have to be careful, make sure that this subject in the external token is actually provisioned as a user with enough permissions in OCI, or with impersonation. So then effectively you have to have some kind of mapping logic, via rules that explain or explain how to basically map that external identity to that service user. Okay, and then the OAuth client validation, that's what I meant by the WIF trust that we're setting up. You have to basically import the certificate so that then we basically trust that external client, that external token, and basically exchange it for a UPST token in OCI. Next slide. Let's have very briefly, this is how this works. External token impersonation rules that map the external user to a service token, to a service user in a UPST token. And next slide. Let's have a look at some of these rules. So this is a rule here. When you're setting up that trust, you're basically saying, okay, if the external token has a subject equal to star, then map to service user X. So any external token with any subject value is going to map this, is going to be impersonated by the service user. You can also do the mapping at group level. So you're looking at the external token, and if the group belongs to XYZ admin, then you map it to an XYZ admin service user. And you can also basically use and do validation on custom claims. So my service user contains XYZ, you're mapping it to this service user. Next. So this is the, I mean, we've covered 2 features now. The final feature here is the high availability and the disaster recovery feature. Let's have a look at the next slide. So in this case, I mean, obviously, OCI IAM is a regional service. So within a region, let's imagine this is the primary region. Obviously, the service is internally within that region. There is already high availability in the sense that a region is comprised of multiple availability domains. Each availability domain is going to have like the application tier and the data tier. The data tier is an Exadata cluster, and the application tier, this is the application tier that runs, OCI IAM and exposes the API endpoints. And you have the load balancer that's load balancing across these availability domains. And each region is usually comprised of 3 availability domains. Some, rare regions are only comprised of 1 availability domain, in which case we load balance across the fault domains, which is a sort of a level of physical isolation within each availability domain, and availability domain here in this case being a data center. So with this setup, we have internally within a region, we have high availability. Now, what happens if we want to basically introduce high availability across multiple regions, right? So we have now this feature, automatic cross-region replication for DR. So we're replicating those availability domains, across region. And we have this traffic steering, DNS traffic steering. In the unlikely case that the primary region goes down, then effectively we switch this over to this internet gateway, to region 2, to the secondary region, and your service works back as normal. There are obviously different levels of replication. There's 2 levels of replication that I'll discuss and explain and expand upon in a further slide. But keep in mind that that's in general how DR works. Now, DR obviously requires replication. So replication is part and parcel of DR, but it's also required even outside of DR scenarios. And that's one example. If you have a tenancy here with multiple regions, let's look at region 1. So region 1 now is my primary region. I have the OCI IAM service. Within that service, you have these security or identity rather resources, groups, users, API keys, etc., right? Tokens. So these are all identity or OCI IAM related resources. They live in region 1. But obviously now, there are policies and there are compartments. Now, compartments, like Kiran explained, are logical mechanisms for us to be able to basically use in order to sort of compartmentalize our resources. Now, a compartment by definition cuts across regions, right? So it's always, think of it as always replicated, always synced across regions. But identity resources are not. So let's see what happens if I attempt to basically point my CLI at region 2 before syncing or replicating these resources. We will end up with a situation like this when I'm trying to execute my CLI, list computes in a compartment. I do have permissions on this compartment as per this policy, allow group XYZ to manage instances in this compartment. So I do have that permission. But what is missing? Something is missing that's actually interfering with this execution, right? And that's it, these resources. So once you replicate these resources, that's it. That statement now works and your CLI now is working, right? Because you have your API keys, your groups and users all replicated. Now, one thing that I would like to mention here is that by default, when we provision you with a tenancy, it comes with a default identity management stack, a default OCI IAM identity domain, right? Now, that default identity domain is automatically replicated across regions. So the moment you subscribe to a new region, automatically gets replicated. But your secondary domains, these are the domains that you spin up, right? Post provisioning. If you spin up a new extra secondary identity domain, then you have to explicitly go into the OCI console and say, I want to replicate it across region 2, 3, 4, and 5, right? Or whatever. So that's one important point. Let's go to the final slide. Now, we discussed about the 2 flavors of DR, right? The first flavor is what you guys get out of the box. Now, as long as you're within a region, or rather, as long as Oracle Managed DR is available within a second region, or where a second region exists within the same geopolitical boundary. So you have a geopolitical boundary comprised of multiple regions, and you're willing to basically do DR across these 2 regions, because the DR obviously implies replication behind the scenes. So you have to be very careful where you replicate your data to. You have to be within the same geopolitical boundary for compliance purposes, of course. So let's assume here, this is the default DR. Your home region goes down, then effectively now your DR region kicks in, but with a limitation. is that you'll be able to basically still log into the console. Your applications, your external applications, like if you're using OpenID Connect, for example, or SAML authentication to connect and authenticate into OCI IAM, you can still use that for inbound authentication. The only thing that will not work though is signature authentication using the CLI. So we have another flavor of disaster recovery. We call that the console enabled disaster recovery. That's where you actually, as tenancy admin, you log into the console and say, well, I want to then set up DR between this home region and this particular region. And in that case, you get the full gamut of capabilities and functionalities, including signed requests. So all your applications, once you fail over, you'll be able to do SSO and application authentication and CLI using signature authentication as well. So this is a new feature that we've introduced that basically effectively, simplifies the DR story. And you can see here in the console, it's just a matter of clicking this option, selecting it, saying enable remote region disaster recovery, and you're done. And these are the three features that I wanted to discuss with you. And that's it from my side. Thank you very much.
Awesome. Thank you. Thank you, Kieran and Mohabben, for a great session today. We really appreciate your time and help. I hope this was a good learning experience for everyone on the call. All right, and then for this slide here, I want to leave you with some more resources to continue your journey into OCI security. So this covers everything from foundational knowledge to hands-on practice and then this slide here. So if you enjoyed this session and would like us to conduct personal training sessions for your organization, do email us at our personal training email and we'll reach out to you. We also have the Code Innovate program or developer experience, and this will allow you to sit down with your team and a group of our engineers for a week and build out a prototype for your use case. From there, you can go ahead and showcase that solution to executive sponsors and deploy the solution that you have developed. Again, the email is there. All right, and then we also have some upcoming sessions. So our next session will be March 16th for security. And in this session, you'll be introduced to architecting secure, scalable networking on OCI. But we do have a lot of other Day One and Beyond series planned and upcoming. We have a series that's focused on artificial intelligence, one that's focused on our AI database. So if you're interested in any of these, feel free to take a look at our Day One and Beyond page where all of these are outlined. With that, thanks for joining today's session and have a wonderful day. Thank you.